This is going to be the fastest video ever, I hope, because we're going to do 4-1, 4-2, and 4-3 all together, and it's going to be really easy. So hopefully you started 4.1 during class, and if not, you need to go ahead and graph all those lines that are listed over here on the graph below. And what you noticed hopefully was that almost everybody each dot's a person. Almost everybody's dot is on a line except poor little Gus over here. He apparently is not any of these things: smart, charming, funny, sensitive, or whatever. So let's go ahead and fill them out. The smart line is blue. So the smart people are Kelly and Al. I thought that said Ali. I think it was Al. And Bree. Charming is red, so that's going to be Elena and Emily. Funny is green, so that's going to be Finn. And I think there's someone down there at the bottom. Finn and Tim. Our sensitive people, that's purple, so that's Al and Ethan. Our athletic people are Lucia or Lucia, Bob, and Emily. And our cheerful people are Lucia and Finn and Bree. Okay, is there only one person for each attribute in question 1? So the answer would be no, because there's a line and there's more than one point on a line. Or more than one, let's even say more than one solution on a line. Okay, what did you notice is different about each of your answers to question 1? I don't know. What'd you notice? I don't know. I didn't notice anything. Different people, because they're different lines. Different lines mean different people. I don't really know what you're supposed to put there. Okay, so who is cheerful and funny? That would be Finn. Who's athletic and charming? That'd be black and red, so that would be Emily. Athletic and cheerful would be black and orange, which would be Lucia. Smart and funny, wow. Smart and funny would be blue and green. There's no one who is both blue and green. No one. And smart and sensitive. That would be blue and purple. That's going to be Al. Okay, so there are people who are two things. Okay, what did you notice that is the same about each of your answers to question 4? They were where lines intersected at each person, right? And each of the answers was where 2 lines intersected. What did you notice that is different about each answer in question 2? There were different lines? So one line, lots of names. 2 lines, only one name. Why do you think there were no solutions for a student that is smart and funny? Because the lines were parallel and did not cross, and so there wasn't a place where there was someone who was both. Okay, so I'm going to see if I can fit in this type of systems. You're either going to have a system that has one solution, no solutions, or infinite solutions. Okay, I'm going to start with no solutions in the middle. Parallel lines have no solution. So parallel lines. And how do you know if lines are parallel? They have the same slope. Okay, infinite solutions are going to be same lines. 2 lines that are exactly the same on top of each other. And they have the same slope and intercept. And everywhere they touch, there's a solution. So there's infinite number. One solution is going to be 2 lines that cross. They might be parallel, might be perpendicular, but they don't have to be. They're just 2 lines that cross. And they have not the same slope. So if they're not the same slope, they're going to have one solution. If it's the same slope, it's either going to be no solution or infinite solutions depending on the intercept, because parallel lines have different intercepts, right? And infinite's going to be the same line, the same intercept, same slope. Okay, so when you look at number 10, the slopes are different, and so there is one solution. Number 11, we're going to have to do what with this? We're going to multiply everything by 5. So we end up with y equals 5x plus 35. Same slope, different intercept, so this one's going to have no solutions. And then we're going to, hopefully, this one's going to have infinite. So let's see, do these lines look the same? They surely do not. So let's divide everything by 6. This becomes a 1, and this becomes a 3. Okay, so now I see 3x minus 1. If I move this 3x over to the other side, it becomes negative. So they are the same. So there is going to be infinite solutions. How do you tell if a point is a solution to a system of equations? Well, same way you do with one line, you substitute in. The difference is that these numbers have to make both of these equations true, not just one. So you're going to have to put these two, 5 and 2, into both equations. So the first one's going to be 2/5 times 5 minus 2 equals 0. So 2/5 times 5 is 2 minus 2, which is equal to 0. And then you have 3 times 5 minus 2 equals 13. 3 times 5 is 15 minus 2 is 13. So this one is a solution. The next one's going to be -2 plus 6 equals 4. That's true. The second one's going to be opposite of a negative, so it's going to be 2 plus 2 equals 2. Not a solution. The next one is going to be, notice the x and y are switched, so it's going to be 6 plus 3 times 3 equals 9. That's not true. So the answer is going to be no, but I'm going to go ahead and do 6 equals 2 times 3. Okay, so if one's true and one's not true, it is not a solution. It has to be true for both of them, like 13 is. Okay. And here it is summed up. A single line has infinite solutions. And 2 lines can have one solution or No solutions, it should really be. Two lines have one solution when the two lines intersect. Two lines have no solution when the two lines are parallel. Can you think of a situation in which two lines would have infinitely many solutions? What would that look like if the two lines were graphed? It would look like one line. Okay. So now we're going to write systems of equations. So this is just practice. We're not actually going to solve equations. We're just going to practice writing the equations. Okay, so these we've kind of like what you've already done before. Now we're just going to do two at a time, and then we're going to figure out how to solve them in a couple days. So your let statement is picking variables for the things you're looking for. So we're looking for apples and pears and the price of each one. So I could use A for apples. I can use X for apples. I usually try to use letters like A and P, and then I'll forget, and I'll use X and Y's in my equations because I forget that way. Okay, so if I'm writing a system of equations for this one, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 apples. So that's 9A plus 1, 2, 3, 4, 5 pears. 5P equals 525. So that's 1. And my second one's going to be 1, 2, 3, 4, 5, 6, 7 apples plus 4 pears equals $4.10. So we're going to talk about how to solve those equations and find out how much the apples and pears cost. But today we're just going to practice writing. So this should be easy, right? Right. What happened? Where's the rest of my thing? Oh, man. Oh, there it goes. Disappeared there for a minute. Okay, let's look at number 2. All right, we're going to a football game. So what are we looking for? We're looking for how many of each kind of ticket were there? Well, we have reserve seats and we have general admission. So R equals reserve seats, G equals general admission tickets. So we have two equations. One of them is going to be how much it cost. So it's $4 times reserve tickets plus $3 times general tickets is going to be $5,792. The other information we have is how many people went. So all the reserve tickets plus all the general tickets is going to be 1,787 people. So those are my two equations. Number 3, we have a flower patch, and we have a length and a width. So L equals length, W equals width. So my perimeter is 48 equals 2L plus 2W. That's my 48 feet. And then I've got this sentence right here. So I'm going to do the length is my equal sign, 2 feet more than, which means I put it at the end, twice the width. So my other formula is L equals 2W plus 2. Those are my two formulas. Number 4. Okay, we're trying to find out how much it costs to ride the Ferris wheel and the water slide. So let's do W equals water slide, F equals Ferris wheel. This one's going to look a lot like the first one we just did. We're going to have Bill's ticket first. So we have 3 water slides plus 3 Ferris wheels equals $17.70. And then for Steve's, 2 water slides plus 3 Ferris wheels equals $15.55. Straightforward, pretty easy. We've already done equations before. Now we're just doing 2 at a time. 15 coins. Okay, nickels and quarters. That's what we're looking for. So, oh, it says quarters and then it says dimes, doesn't it? Let's assume that's quarters. So N is going to be nickels. Q is going to be quarters. So I know that there's 15, so nickels plus quarters equals 15. And then here's this thing right here, 3 more nickels and quarters. So I'm going to add 3 to either quarters or nickels. If he has 3 more quarters, that means he has more quarters. So I'm going to add the 3 to my nickels because quarters is what he has more of. So if I do nickels plus 3, that's going to be how many quarters he has. So there's my 2 equations. All right, number 6. Complementary angles. Add up to 90 degrees. So I have S and T. S equals angle 1. T equals angle 2. S plus T equals 90. And T is my equal 5 less than twice S. Remember the less than makes it go to the back. So T equals 2S minus 5. And there's my 2 equations. So that's totally easy. We're just writing 2 equations instead of 1 equation, and then we're going to figure out how to solve them. Not today, but tomorrow. Because today we're going to find solutions just by looking at graphs. Okay, so I'm trying not to say okay because someone told me I said okay too much. Let's plot, well, let's fill out the answers, I guess, down here. Okay, initial weight of alligator 1 is 4 pounds. Initial weight of alligator 2 is 6 pounds. How much is the growth rate for alligator 1? It's going up by 1.5. And I'll go ahead and look at this one. This one's just going up by 1. So the growth rate of alligator 1 is 1.5 pounds per month, and alligator 2 is 1 pound per month. Okay, so for our variables, let's have time and weight, because we're doing months and weight. So we're doing time is month. Oh, let's do this. X equals time. Y equals weight. Alligator 1 is y equals 1.5x plus 4. Number 2 is 1x plus 6. So let's graph the equations. And I'm just going to use the point since I can't see my equation over here. So I'm going to do little x's for this one. 0, 4, 1, 5.5, 2, 7, 3, 8.5, which makes 4, 10, 5, 11.5, 6. Okay, that's alligator 1. Alligator 2 starts at 6 pounds. 1, 7, 2, 8, 3, 9, 4, 10, 5, 11. Okay, so if you can look and see, there's a place where they cross. Right there at month number 4. So month number 4 is a solution for these 2 lines because at month number 4, the lines cross, so it's a solution. Okay, what happens at the 4-month point? Lines cross. And what does it mean when the lines cross? The alligators weigh the same. So the place where they cross is the place where the solution is the same. The 4 months, alligator 1 weighs 10 pounds, and 4 months, alligator 2 weighs 10 pounds. So at the same time, the same weight. That's what a solution is. Okay. Number 6. The variables are X is books and Y equals dollars. So for income, Y equals, I'm going to use this to find my slope. Actually, I'm going to write it right here. M equals 200 over 100 equals 2. So it's going to be 2x, and it starts at 0, so I'm done with that one. The slope for this one is going to be 1104 minus 864 over 300. 1104 minus 864 is, I'll write it down somewhere so I wouldn't have to do it again. 240 over 300. Take those zeros off. So I have 24 over 30, which is divide by 6, 4 over 5. Okay, so for my expenses, Y equals 4 over 5x plus 864. What happens when the expert sells 700 books? His income and expenses are equal. We call that breaking even. So think about it. It's not till he sells 700 books before he even starts making money. So as soon as he sells 701 books, he actually starts making money. Yeah, sad, isn't it? Oh, there's my llamas. That means we're almost done. Yay! Okay, last one. Satellite radio services. So X is time, Y equals cost or dollars. So for number 1, it's going up by 10. So I have Y equals 10x plus, if I go back to 0, if I subtract 1 and get to 0, I subtract 10 and get to 20. So it's going to be 10x plus 20. And for number 2, it's going to be Y equals, this one's going up by 11, so it's going to be 11x. And if I take away 1 and I take away 11, I end up at 15. So this one's going to be Y equals 11x plus 15. Okay, so start at 10, and I'm going to go up 20. So 1 and 30, 2 and 40, 3 and 50, 4 and 60. That's number 1. My next one's going to start at 15, 1 and 26, 2 and 37. It's kind of going to creep up on this one. 3 and 48, 4 and 59. And if I actually went to 5, they would both end up at 70. So 70 and 5 is going to be the solution. Because if you get either service, so if you want cheap and you're not going to keep it for very long, for a couple months, you would go with number 1. Oh, I should have started this one at 20. I was like, why does that look wrong? Because that one should have started at 20. So this one is more expensive, and service number 2 is cheaper until you get to 5 months. So if you're going to keep it less than 5 months, number 2 is cheaper. If you're going to keep it for more than 5 months, number 1 is cheaper. So at 5 months, same cost. That's my solution. That's my llamas. If that doesn't make you happy, I don't know what will. See you Monday.